My name's James, and we're Team Alpha, and we'd like to introduce you to uStar. uStar is a child monitoring app that was produced as an incentive for promoting good behaviour in children. It was inspired by a friend who wanted a way of rewarding their child for good behaviour. Myself and Shalom will now give you a brief demonstration of the app and give you a feel for how it works. So please sit back and enjoy. When a parent opens the mobile app, they will see the main home screen. From here, they can click on a number of options. First, we will click on the How to Use button. On the How to Use screen, it shows how to set tasks and rewards. The parent will now sign up so that they are able to use the app. I will now sign up using Firebase authentication. Now that Tom has signed up, he's taken to the main profile page. Here he can see his name and his email address, and he can add a child so that they are able to use the app. Now that Tom has added his child Jim, he can see Jim's name, his star count, and he can set him tasks and rewards on the next page. On the task page, Tom can now set Jim a task. And now Tom can set a reward for Jim too. This gives Jim something to aim for, even if I do say it's a steep price. Once Tom is finished with the tasks and rewards, he can go back to the profile page where he can see the login code for Jim so that Jim is able to sign up. I will now pass it over to Shalom, who will run through how Jim will sign up.
We designed the child login process to make it as simple as we can for the child. They don't need to put in any of their own data. All they need to do is get the login code from their parent and put it into their phone. Once the child is logged in, he can now see his rewards, his tasks page, and his rewards page. He's able to buy rewards, remove rewards, and if he would like to, he can add his own rewards. Once Jim feels like he's cleaned his room well enough, he can click Request Review, which will change the task status to pending. When Tom logs back in and views Jim, he can see that he has changed the task status of clean room to pending. Now he can go and check Jim's room to see it's clean. Now that it's clean, he can confirm requests. Now the task status is automatically changed to completed, and Jim has increased his star balance by 5 stars. Now Jim can see that his parent has marked his task as completed and that he's gained 5 stars. So now he can go onto his rewards page and spend the stars whichever way he likes. Jim chooses wisely. Now that he's bought the ice cream, we can see that his star count has gone back to 0. I will now hand it over to my colleague Adil, who will describe the tech stack we used in the back end of our project.
The tech stack for our backend was based on NodeJS with the Express framework. We went with Postgres as our database management system, which we were already familiar with and needed a relational structure in order to have the parents and children easily connect together. We used knex as a query builder as it's easy to use and kept our code clean by allowing us to use promises. Miscellaneous utility functions we created to manipulate our data we unit tested using jest, which includes both a test suite and an assertion library. We then tested our endpoints using supertest. Finally, we hosted the backend to our app on Heroku, which allowed us to quickly deploy it so our front end could begin to make its requests.
For the front end, we wanted to use new technologies we didn't learn on the course, such as Expo and Firebase. We wanted our project to be on iOS and Android platforms, which gave us a choice between Expo or React Native. We chose Expo over React Native because React Native had different modules for Android and iOS, which meant you had to code separately on the front end for Android or iOS platforms, and this was not feasible in the time given. Expo, however, builds on both platforms with the same line of code. Expo also has over-the-air deployment, meaning we don't need to deploy on Google Play or App Store, and it automatically updates on the deployment. Axios was also used, as we were most comfortable with it on the course, and it also had the added benefit of automatic JSON serialization, unlike Fetch. Firebase was also used for authentication while logging in as the user. Firebase was also used for authentication while logging in, as we wanted to secure user information that was sensitive. Next, we'll go over to the challenges. One of the challenges we faced on the project was remote collaboration due to lockdown, which was solved by using Slack, Zoom, Discord, and LiveShare, as well as using agile-inspired practices of stand-ups, pair programming, and regular check-ins. Another problem that we faced was spiking and adjusting to Expo and Firebase. We recognised how big these technologies were, and by splitting into pairs to learn Firebase and Expo separately, we knew we could learn as much as possible. A third problem that we faced was Firebase in React versus React Native. Now, during our time together, I realised that James learnt Firebase in React instead of React Native, and in order to address this, we created our own login sprint to get the functionality that we wanted.
Throughout the project, we made use of many agile practices. Each morning, we had our daily stand-up and regularly checked in with the team throughout the day. Our tasks were displayed clearly on Kanban boards on Trello, which allowed us to visualize progress and adjust the course of the project if necessary. We made use of pair programming and even mob programming when we needed all hands on deck. Our independent researching skills were honed when spiking our tech stack and reading new documentation. Due to the nature of working remotely, naturally, we improved on how to communicate and work with each other effectively over long distances.
In the short time we were given, we were able to achieve the core functionality that we set out to do. However, there were some extra features that we would have liked to have added to improve the user experience. As we are dealing with potentially sensitive data, we plan to add an encryption key onto our API so that only app users would be able to access their data and only their own data. We also looked into creating push notifications so that when a parent would set a new task or a new reward, or reward some stars, the child would be immediately notified. Additionally, when a child would request a task review or spend stars, the app would notify the parent. We also thought it would be useful for the parent to be able to change their password and to be able to generate a new login code for their child.
Stylistically, we could easily add in a day-night theme feature and an image picker for children to select their own avatar. We even thought about social media integration, but decided it might not be suitable for younger children. However, an internal leaderboard with parent-approved friends or siblings is something we could choose to implement in the future. Overall, we are proud of what we managed to achieve in 2 weeks, as we completed all of our core functionality and created an app which we are happy to share with you today. Thank you for listening, and we are happy to answer any questions that you may have.